In this session, we will discuss about DHCP. DHCP stands for Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. DHCP is a application layer protocol. Remember this point. Application layer protocol. Application layer protocol means it works at layer 7 of the OSI reference model. DHCP use UDP as a transport protocol and UACP use two port numbers 67 and 68. 67 port number is used by DHCP server and 68 port number is used by DHCP client. First remember these 2 points, very important. DHCP use UDP. DHCP works on top of UDP and its port numbers 67 and 68. 67 is a server port number, 68 is client port number. Now what is the use of this DHCP server? The DHCP server purpose is the DHCP server will assign IP addresses to systems automatically. Means it provides the IP address to all the systems. In the first class in CCNA, in the starting class we have discussed, right? If you want to configure IP address on system, we have two methods. One is the static method, second one is the dynamic method. Static method means we will assign IP address manually. Dynamic means system will get IP address from the DHCP server. That is a dynamic. If you want to get the dynamic IP address, you should have the DHCP server. Without DHCP server, systems cannot get the IP address. See here, if you see IP configuration in the system, here we have two options, DHCP and static. Static means manual IP address, like we need to configure like this 192.168.1.2 and a mask gateway. This is the static IP address. But dynamic means, so here we need to click, okay, see here, DR. If you have a DHCP server in your company, just click on DHCP and then what happen? It will send the request message and it will get the IP address. This is a dynamic. If you don't have a dynamic IP address, we can't get the IP address. So first we need to configure the DHCP server. So DHCP server can be configured on any device. We can use dedicated server. We can use one dedicated server for DHCP. Like we can use DHCP, Windows DHCP server. Windows, we can enable DHCP service on the Windows server. We can enable DHCP on Linux server. We can enable DHCP on the Cisco routers. We can enable DHCP on the firewalls, load balancer. Everywhere we can enable this feature. So now I have a router. So I will use router as a DHCP server. So how to make router as a DHCP server? So generally what DHCP provides to clients? DHCP server provides IP address, subnet mask, gateway, domain name. So DHCP server provides these four things to every system, every client. Okay. Now, so I will configure a router as a DHCP server. Okay. So now I will show you how to configure DHCP in Cisco router. Okay. So commands are very simple here. We have only 4 commands. I will configure commands directly on router. Okay. So first you configure this interface F0 by 0. Click on here, CLI, and see here. First now enable configure terminal hostname R1, interface F0 by 0, IP address 192.168.1.1, 255.255.255.0, shutdown, exit. This is the interface configuration, right? Now configure DHCP. First we need to configure pool. What is the pool? This is the network, right? This is my LAN. For this LAN, we need to configure one pool. If you have a 2 networks, we need to configure 2 pools. If you have a 10 networks, we need to configure 10 separate pools. For each network, we require one pool. Okay. So in this pool, for this network, what is the gateway? Gateway is 192.1.1.1. What is the DNS IP address? DNS IP address, whatever we have a DNS IP address in your production, we will use that IP. Okay. See now, IP DHCP pool. Pool name LAN. You can use any name, not only LAN, you can use any name, LAN, ABC, XYZ, or HR, IT, finance. You can use any name. And network. See here, now we are in DHCP configuration mode. So here we need to specify network. What is the network? Network 192.1.1.0, mask 255.255.255.0. Next, default gateway means default router. Default router means default gateway 192.168.1.1. And the next, DNS server. DNS server IP 2.2.2.2. That's it. Domain name. For example, Cisco.com. Exit. This is DHCP configuration. DHCP configuration. Okay. Now we can get IP address from router. See here, go to system. Here, no need to configure IP address manually. See, just click on DHCP again. See 192.168.1.3 subnet mask and gateway and DNS IP. This is the dynamic IP. We got this IP address from DHCP server. Next, here next desktop IP configuration, and here DHCP. Here, yeah, got it now. 192.168.1.4. Next, here DHCP. So now our router is a DHCP server. So router assign router distribute IP address from 192.168.1.2 to 192.254. Okay, means whenever this DHCP server receives any request from any system, any client, it will assign in between 1.2 to 1.254. When it is assign IP address to any client, it will record internally. So this is called binding. DHCP bindings. How to see these bindings? Now see here. So go to here in the privilege mode. Show IP DHCP bindings. See, these are the bindings. This is the MAC address. For system MAC address. See, 1.3, right? So where is 1.3? This one, right? This is the 1.3. What is the MAC address of this PC? Command is ipconfig /all. See, this is the MAC address. Right? Same MAC address, right? IP 2D49, right? Last. 1 second. Okay. And this system MAC address ipconfig /all. Copy. And here ipconfig /all. Now see here in the DHCP binding table, we can see these IPs, see these MAC addresses. See here 2D49. For 2D49, this is the system 1. Assign IP address 192.168.1.3. And AE17, system 2, AE17. Assign IP address 192.168.1.4. And 72B8, third system, IP address 1.5. So this is the binding table. DHCP records all the information in the DHCP binding table. So basically DHCP server assign IP address based on the MAC address. Okay. So this is the DHCP configuration. Now we will discuss how this DHCP communication happens. Okay. Now see here. For example, I am going to assign one, or I am going to connect one more system in this network. Okay. So now we need to get the IP address from the DHCP server. So now actually what happened here? First of all, my question is here, how this PC will get IP address from DHCP server? So if this PC wants to get IP address from DHCP server, first this PC should send request message, right, to server. Then only server will assign. Server will not assign IP address automatically. Whenever DHCP server receive the IP address, receive the request message, then only it will provide the IP address. Okay, remember this point. But in this case, how this server, how this system will send discovery message? How this PC will first will get to know who is the DHCP server. See here, in this network, total how many devices are there? In this network, total devices are 1. Total is 1, 2, 3, 4, 5. Total 5 devices are there. In these 5 devices, which is the DHCP server? How this PC will get to know first of all? Right? Then only this router and then only this PC can send that request message to server, right? First of all, how this PC will find out who is the DHCP server in my network? In my network. So here to find out DHCP server in local network, the first client PC means this PC sends one message. That message is called discovery message. Which message? Discovery message. Discovery message means it will discover the DHCP server. Who is DHCP server in my network, like that. So means this discovery server is the broadcast message. It will send the broadcast. So broadcast message means it will send to the switches, which will flood that message to all the devices. But the system will not respond. The system will not respond. The system will also not respond. Only router will respond because it is DHCP server, right? This router will only respond now. I am the DHCP server. So what you want, like that. So this response is offer. Means DHCP server will provide the offer message. Yes, I am the DHCP server. What you want? Tell me, like that. Then this system again send one more message. That message is request message. That message is what? Request message. Yes, I want one IP address, like that. And then finally server will send the IP address and it will send the acknowledgement. This is process. This process is called DORA. DORA. Discover, offer, request and acknowledgement. This is very, very important in the interview. This is most common interview question. What is DORA process? DORA process is discover, offer, request, client. The first client PC sends discover message to find out DHCP server in local network. If the DHCP server is there, the server sends offer message. And then it will send the request message. And finally, server will send the acknowledgement. This is communication between DHCP client and the DHCP server. Right? Now we will discuss about APIPA. It is also very, very important. APIPA. APIPA means automatic private IP address. Automatic private IP address. For example, here, see, listen carefully here. This is the client PC, right? This PC has sent discovery message to DHCP server. Not a DHCP server, this PC has sent the discovery message. But this PC has not received any offer message from DHCP server. What happened? Maybe maybe in this network DHCP server is not available, or maybe DHCP server in shutdown state, or maybe some network issue. For any reason, If a client is not receiving after message from DHCP server, so actually what happened? So then what happened? The client PC will automatically assign IP address, APIPA IP address. The APIPA IP address is 169.254.0.02, 169.254.255.250. This is the APIPA address range. Remember this range. 169.254.0.02, 169.254.255.255. So IP address starting with 169.254. Remember this point. Whenever you see IP address starting with 169.254, we have to understand this is the APIPA address like that. So APIPA IP address is automatically assigned when client system is not receiving offer message from DHCP server. My question is here, what is the use of this DHCP server? For example, here, this is the client 1, client 2, client 3, client 4. For example, this PC has received IP address from the server. This IP address is 192.168.1.2. The system has also received IP address from server. So this IP address is 192.168.1.3. And this system has also received IP address from DHCP server. That IP address is 192.168.1.4. But when this fourth PC, when this PC sends discovery message, this PC has not received after message. Means then what happens? The system will assign IP address like this 169.254.0.1 or 0.0.3, whatever it may be, some number from this series. But now here, okay, correct. So now these two PCs can communicate or not? These two. If you send any traffic from 169.254.0.1 to 192.1.1.2 or vice versa, can we communicate or not? We cannot communicate, right? Why? Because both are different networks. But what is the use of this IP address? If this PC cannot communicate with any other PC, but what is the use of this IP? Why system use this IP address? The purpose of this IP is APIPA IP address is to reduce the broadcast traffic. See, again, I will explain one more time. So this PC has sent the discovery message. Discovery message is the broadcast message, right? Broadcast message means every PC will be received, right? Including server. So this router will receive broadcast message, this PC receive broadcast message, this PC will receive broadcast message, this PC also receive broadcast message. But no one is responding here. Means the system is not getting after message. If it is not getting after message from DHCP server, again it will send the one more discovery message. If it is not getting again it will send the one more discovery message. If this PC is sending discovery message continuously again and again, what happens? This is the broadcast traffic, right? This broadcast traffic consume system resources and network bandwidth. So what happened here? Automatically network performance will be degraded. This is the problem with the broadcast traffic. Control this broadcast traffic, system will automatically stop this broadcast messages. To stop this broadcast messages, okay, system will assign automatically APIPA address 169.54.0.1. This is the main purpose of APIPA address, automatic private IP address. Automatic private IP address. Very, very important. So in this topic, the most important questions in the interview, what is the DORA process? DORA means discover, offer, request, and acknowledgement. This is the most common, frequently asked question in the interviews. And next to APIPA address. What is the APIPA range and what is the use of this APIPA address? You should keep in your mind APIPA address range. It is any IP address starting with 169.254. That's it. Any IP address starting with 169.254 is APIPA address. After 254, it can be any number 0.1 or 1.1 or 2.1 or 3.1, any number 0.02 to 55.255. Okay. So in the next session, we will discuss about DHCP relay agent.